Hello everyone, welcome to my presentation. My name is WEIJIE, and my student ID is JRN2409028. Today I want to talk about a very interesting topic in our course, the optical property of the parabola. And my lecturer is Professor JRN2409028. Before we start, let's look at my overview. First, I will show you some common things we see in life. Then we will look at the strict math definition and prove the core property. Finally, we will use our proof to explain how real technology works. The first part is introduction. Let's look at these examples. It's satellite dish, and this is solar furnaces. We call them collector, gathering energy from infinity. Have you ever wondered why they all have this specific curved shape? These dishes are designed to catch very weak signals from deep space and focus all that energy into one small point to get a clean reception. This is how we get satellite TV and clean solar energy. Now look at these examples, car headlights and flashlights. We call them projector, engineering the perfect beam. They do the exact opposite. They take light from a tiny bulb and turn it into a very straight, powerful beam. This beam doesn't scatter. It goes straight ahead to help us see the road at night. The question is, why does the same curve, the parabola, work for both gathering and sending out waves? Let's find the answers in math. To solve this mystery, we first need to know what a parabola is. According to Thomas calculus, a parabola is a set of all points P where distance from P to a fixed point called f focus F is exactly the same as the distance to a fixed line called directrix L. Its directrix L. So the PF equals to PQ. And the mathematical identity is dPF equals dPQ. And in our coordinate system, the standard equation is y squared equals 4ax. In this equation, the parameter a is distance from the end point to the focus FA0. The line at the back is the directrix x equals minus a. This a value is very important because it tells engineers exactly where to place the sensor or the light bulb. Now let's look at the main part of my project, the refractive property proof. First, we see this figure. Imagine a ray of light starts at the focus FA0 and hits the parabola at the point P x0, y0. We want to prove that after it refracts, the light goes perfectly parallel to the x-axis. To do this, we use the law of refraction. For any refractive surface, the angle of the refraction beta is congruent to the angle of incidence alpha. And our goal is aim to prove that when alpha equals beta, the refractive ray is parallel to the x-axis. The x-axis is the axis of symmetry. And the details given is the standard equation y squared equals 4ax. And the focus is FA0. And P is x0, y0. And the T in x-axis is minus x0, 0. The secret of the proof is showing that triangle TFP is an isosceles triangle. Let's do it in 3 steps. The first step is calculate Lagrange of base TF. It's easy to calculate TF. We know the coordinate T is minus x0, 0 and F is a0. So the TF is a plus x0. The next step is calculate the Lagrange of set PF. By the definition of a parabola, the distance from P to the focus F equals its distance to the directrix x equals minus a. So the PF equals PQ. So we know the PF equals PQ is x0 plus a. Compare with the TF and the PF. So we know the PF equals TF. and the TFP is the associated triangle. So the alpha equals to the FTP, and we know alpha equals beta, so beta equals to FTP. And we know beta and FTP are alternative interior point angles. So the refract ray parallel the x-axis. Next, let's talk about the principle of reversibility. The principle says that light can travel both ways on the same path. So if light from the focus goes out parallel, then any parallel light coming in must go straight to the focus. The dual nature is why one shape can do two different jobs. The path of light ray is independent of the direction of travel, because the law of refraction of equals beta holds true in both directions. The geometric proof remains valid whether light is entering or leaving the parabola is from the fundamental of the physicals. So direction A is the projector light from focus to parabola outward. And direction B is the collector, parallel light to parabola to concentrate at the focus. By proving the geometry of the tangent and associated triangle TFP, we have proven the mathematical foundation for both the projector and the collector at the same time. Next part is real-world application. Let's go back to our examples. In satellite dishes, parallel signals from far away hit the surface and focus at point F. Engineers place the receiver exactly at the focus to get a strong signal. So is the parabolic curve is here, and the signal from infinity is parallel is here, is the pink line, and is concentrated on focus. This is the receiver focus. The core concept is based on the principle of reversibility. We just established an incoming ray parallel to the axis of symmetry must pass through the focus of refraction. This incoming ray is parallel and concentrated on the focus. And next is projector. This is flashlight. This is flashlight. And this is the focus. And after it reflected, hit the parabola is parallel, refractor ray is parallel. So the parabolic reflector ensures the light stays in a direct column rather than wasting energy by scattering in all directions. And this is direct application of our main proof. Light originating from the focus reflects off the surface to form a parallel beam. This is the parallel beam. And the last part is conclusions. We define the parabola as a locus of points based on the focus directrix property. This is a mathematical definition. And after that, we provide a strict proof of the refractive property using coordinate geometry and the algebraic properties of tangents. And last, we applied the principle of reversibility of light to show the parabola functions as both a collector and a projector. So after that, we know the parabola is not just a curve or graph, but a fundamental mathematical tool that powers modern communication, energy, and safety technology. And this is information used in our project. This is Thomas calculus, and this is fundamentals of physicals. So that's all my presentation. Thank you.